Okay, who can tell me what logarithms do? Yes, they solve for the exponent. The purpose of a log is to find an exponent. Now this is a fairly obvious one. It says, if you have a number, which you could write with a base of 5, like this is a base of 5, 5 to something, what exponent would you raise it to equal this? So this is a really obvious one. You're saying, what could you raise 5 to equal 5 to the 7th? Well, obviously it's 7. You would raise 5 to the 7th to get this. Most of them are more like log base 5 of 25, meaning what could you raise 5 to equal 25? Those are the ones you have to think a little harder about. But you're correct, it is 7. Now let me ask you this. What is, no it's not on, I know how to work this thing. What is log base 5 of 5 to the first? 1, yeah. What would you raise 1 to? What would you raise 5 to equal 5? 1. You're correct. Now today we're just learning 3 very, very simple log rules. And we're not going to punch anything into the calculator. All we're working on today is rewriting logarithms. And the first of the 3 things I'm going to show you is, when you have an exponent in a log, all you have to do is bring it down. Because the answer to this was 7, right? Wouldn't the answer to this be 7 as well? Log base 5 of 5 is 1. 1 times 7? 7. That's the first of the 3 rules. When you have an exponent in a logarithm or natural log, because they're the same thing, you just bring down that exponent and you stick it in the front like a coefficient. Good question. So if I gave you this question today and I just said rewrite it, you don't have to solve anything. You would just rewrite it like this. 7 log 5 of 5, so that you no longer had an exponent. Yep, you got it. Let's quickly just go over the 3 rules. Here's all 3 of them all at once. Boom, right there. The first one, the third one we just talked about. You have an exponent, bring it down, and now it's multiplication. These 2 simply say, if you're taking a log of a product, you can break that down as the addition of 2 logs. Number 2 says if you're taking the log of division, of 2 things being divided, you can break that down as to the subtraction of those 2 logs. Only difference. And that's all we're doing today is those 3 things. Math. This is more of a, logs are really more of a science thing than math. I mean, you need math in science, but mainly the only people that use logs are the people that study quantities of very small things. Like hydrogen molecules in a hot air balloon. There are going to be billions, and you'd use logs to figure out how many you would need to get in there, blah, blah, blah. Anywho, you want to write down those brief things? I have like 4 slides that say the same thing. This is essentially the only piece of notes we're taking. The very next slide says the exact same thing, but in the opposite order. Which you don't have to rewrite. It simply means sometimes today it'll be advantageous for us to change this into this, and sometimes it'll be advantageous for us to take this and change it to this. Yeah, it's all depending on what our needs are at the time. But basically, you just need to know it can go one way or the other. And we're going to be doing both today, but it'll tell you in the direction of which one to do. Let me ask you this. If the direction said you are expanding the log, which one do you think, what order do you think you're doing it in? Left to right or right to left? If I said you were expanding it. Yeah, left to right. This one's longer. You're expanding it. If it says, rewrite it and simplify it, you think you're going right to left because you're making it shorter. So, not to mention the directions will be obvious. Because if you're given this, that's obviously what you need to do. And if you're given that, that's obviously what you need to do. So, common sense shall prevail. Anybody still writing this? I think it's, dang it. Never mind, I'll wait. On page 350 something. But Of course. Saw Brayton there. Who's the only person out here right now. Because he left. He's signing out. I love fish. No. Did they have them there? Oh, I didn't go to the carnival. I just went to the tent. I've never gone to the carnival. I always go to the tent. Oh, I've had one. They are good. They're very fattening. Okay. Here we go. Let's just jump straight into the problems. Let me stop you there for a second and say you're about 2 or 3 minutes late to this conversation. Because that's exactly what we were just talking about. Okay. Here we go. Now notice, to answer your question, I have tried one, but not in a long time. Okay. So, it says, where possible you can evaluate these logarithms. I'm not going to make you do that because I wasn't planning on having these calculators. Essentially, what that was saying was anywhere you can find an exact number answer, do it, but you don't have to. All we're doing today is expanding these and condensing them. Here, we're going to expand them. So, number 1, how can I change this? Very good. Don't forget your base. Of course, all this was assuming you have the same base all the time, but you will all day, so. There's no 9. That's a log. Log base 5 of 7 plus log base 5 of 3. Number 7 would just be log base 7 of 7 minus log base 7 of x. See, number 7 is a classic time of where subtracting would actually make this simpler because log base 7 of 7 is what? 1. So there's no point in doing this one. 1 minus log base 7 of x would be much more to the point. But anyway, that's neither here nor there. You got it. And everything on this page is the exact same thing. Notice, the ones without a base, then you don't have to write a base. What that actually means is that it's a base of 10 because that's the natural base. Log is kind of like scientific notation in that it just naturally works with 10. But you don't have to. If there's no base, then don't write a base. Questions about anything you see on the screen? Would somebody like to see one of these? If there's no base, then don't write a base. 1,000 plus a, yeah, log of x. Yep. Anything somebody'd like to see? Okay. Let's step up the difficulty a tad. All right. Now, natural log works the exact same way. So, what's the first thing I need to do? 13, yes. E squared minus, that's right, because it is, now, what else can I do? Exactly. Exponent comes down, so that becomes 2 natural log of e minus the natural log of 5. Now that would be a very simple thing to plug into your calculator because e is just a number like pi, but you don't have to. Yes? Only difference at all is that log has a natural base of 10 and natural log has a natural base of e. But since we don't even worry about the bases right now, for our intents and purposes, there are no difference. Yes? Yes, they would. Very good. But we're not even going to worry about that right now. But you're right. Okay, let's see. What's the only thing I would do on 15? Yeah, bring down the 3. That's it. You're done. Bring down the exponent. Does anybody remember from yesterday, a root is the same as a what? Fractional exponent. So 19 is the same as what? As x to the what? 1/5. And so that would become 1/5 natural log of x. Muchos goodos. Let's look at 23. Who wants to start me off? Adam, I think you can start me off on this one. 23. When in doubt, just say log. Okay, good start. Well, let's just take the numerator first. Now, when I'm dividing, do I add or subtract? Subtract. So minus log base 4 of 64. There's really only one thing I have to do, and what's that? That's right. A square root is the same as x to the 1/2, so that exponent would come down to be 1/2 log base 4 of x minus log base 4 of 64, and you are finished. Square root. Same place over here, we got the 1/5. Square root is a 2. No, the 64 is not an exponent. It's just a number. You only bring down exponents. Like number 17 would have just been -6 log of n, because it's an exponent. Let's look at 27. I didn't pull it aside. Oh, 35. Good one. Yeah. 35 is a good one. What do you think comes first in our order of operations here with this log? That's right, the root, because everything is under that root. So what do I do with it? Now, if you're not going to pay attention to any other problem today, make sure you pay attention to this one. I do believe every single student in my last class asked me about this problem on the actual assignment. So please pay attention. All right, what? That's right. So first thing, this becomes basically the whole thing raised to the 1/3 power. So we're going to bring down the 1/3. Now, easiest way to do this problem so that you don't have to worry about distributing and everything later is just start putting everything in parentheses and leaving the 1/3 out in the cold. Because people are like, well, you know, does the 1/3? Yes, the 1/3 goes with everything when you start expanding this. But to spare yourself having to write it so many times, just put it in parentheses. So, now I have 1/3, and what happens in here? Crystal, what happens in there? Let's just break down the top and bottom first. That's right. Now, let's break down the first term. What would I do there? Notice how I'm just leaving the 1/3 outside. Don't deal with it again. Careful. The 2 would not go with the y. So, technically what you want to do is first break up the x squared and the y via addition. Now the only thing left to do is what? The 2. Comes down here, making that 2 log 5 of x. Now when you are done, you're more than welcome to distribute the 1/3. That would be 2/3, because that's now a 2. It'd be 2/3 log base 5 of x plus 1/3 log base 5 of y minus 1/3 log base 5 of 25. Or we can just leave it out there. I don't care. But you are going to have one like that in your assignment. And my challenge is for nobody to ask you about number 36, because it's almost exactly like this one. So if you have a question, please ask it now. About why we did something, how we did something, anything like that. Yeah. Sure. I mean, you can distribute, but you don't have to. Yes. That's as expanded as you can get. It has to be bring down to 2. The way it's written in the original problem? Yes, you won't have one like that today. And the reason you won't is because that gets a little complicated. But yes, you could. Okay. Yeah, right here's the power rule. We brought down the 2. Anytime you bring down a power, it's a power rule. Okay, next batch of problems. Oh, first off, if you want to look at everything on, This page, make sure there's none on there that are different than anything that we've seen. It'll be 1/2 parentheses log of 100 plus log of x close parentheses. 33. You may just jump to the answer or break it down. Break it down. So first thing you're going to do is break down the top and the bottom. This is 33 we're working on now. First thing you do is just break everything with addition, subtraction, and then there's just 3 power rules. You bring down the 1/2. Well, that would be lazy. Bring down the 3. Then you bring down the 3 again. You don't even need parentheses anyway on the bottom. Do you have any questions about something that I've written? Nope. Yes, sir. With which one? Well, that's not 31. That's 33. Does it make more sense now? First thing I did was break it down. I put this one by itself, this one by itself, addition because it's multiplied, and then I subtracted this one because it's divided. And then all I did was power rule 3 times. 1/2, 3, 3, and that was it. Does that make more sense now? Yep, definitely 33. Other questions from that slide? All right. Only one slide left, and that's this one. This is the same exact thing, except we're working in the opposite order. So now, instead of you taking a coefficient, exponent and turning it into a coefficient, you're going to go in reverse. So like 53, everywhere you see a number in front, that's going to come up here and be an exponent. So 53 would be log base b of x squared plus log base b of y cubed. Now, what can I do with addition? Turn it into what? Multiplication. So it becomes log base b of x squared y cubed. And that's as much as you can condense it. Remember, condense making it smaller, expand making it bigger. Every coefficient. Now remember, a fractional coefficient, the 1/2, those are going to become what? What are the 1/2 going to become? Square roots, yeah, what? Well, that's what it asks us to do. It asks us to condense it. So we transferred this into this. Much simpler as far as to write. All we did was do the power rule twice in reverse, putting them up here. And then with addition, we bonded them with multiplication. Let's just jump straight into the hardest one on this page, in my opinion, and that's 65. 65. All right. Michelle, you want to help me out with this one? Thank you. Go. No. Yeah, you tell me the process. Okay. So basically I'm going to... Okay. You're absolutely right. The 2 can go and come up here. Although over here you can condense that. This was a tricky one for me to start you into. You can condense this before, you can go and simplify what's in the parentheses if you can. The one on the right, this one over here, you can't do anything with x plus 1. But this you can condense. And how would I condense that? Yes, x, y. And then this one over here would stay the same, the rest of the problem. You do not have to FOIL today. I think you're noticing that you could FOIL x plus 1, but just leave it. That looks simpler anyway. So what's the last thing over here on the left? Very good. Very good. Very, very good. Last thing to do, because it's subtraction, is this comes down here. Yep. And this is your final answer. Notice all I did was I kind of morphed that step. This was originally what it was after subtraction, but then subtraction just takes this. Now the whole point of this is to turn it into one big log function. That's why I didn't bother writing log again. It's log of this whole thing. And that's the hardest one. Just remember your order of operations. If there's something you can do inside parentheses, do that first. If there is. This one you couldn't, that one you could. Question. Sure. Yeah, I don't care if you show me any steps. I just want you to know where it's coming from. Question? Okay. I had a review portion on this as well, but we're going to postpone that because my other class didn't have to do it because we didn't have calculators, so I'll spare you until tomorrow as well. Every other even, that basically means you're going by sixes. So 6, 12, 18, 24, etc. You can count by sixes. Yeah, it's basically every sixth problem.